Hey PreCalc students, this is a video that will help you work through section P1 and P2 in your pre-calculus book. The first thing we need to review to get ready for our year of learning pre-calculus is the real number system. So remember, a number is either real or imaginary. If it's imaginary, it's going to be in the form of a plus bi. I is the value of the square root of -1. We'll talk about that here in a minute. If it's not an imaginary number, of course, it's a real number. So I'm going to start from this chart at the bottom and then work my way to the top. So our real numbers are anything that is not imaginary. Up from real numbers, we can divide those into two categories, rational numbers and irrational numbers. Irrational numbers are numbers like the square root of 2 or pi. Those are numbers that you can type in your calculator, and your calculator will display a certain number of decimal places, so like 3.1415, blah, blah, blah. Eventually, though, it's going to have to truncate because our calculator can only show so many digits. Irrational numbers are numbers that have repeating, or non-repeating decimals, and kind of go on forever in the decimal direction. Rational numbers are numbers that can be written as fractions. So I always kind of hear the word fraction in rational, sort of. I don't know, that maybe would be a stretch. But some examples of rational numbers would be 3. Now, 3 is a rational number because it could be written as, oh, I don't know, maybe 15/5. Another rational number would be 2.7, because that's the same as 2 and 7/10. So that's a fractional representation of the number 2.7. So really, there's a whole bunch of rational numbers. But again, the biggest difference between a rational number and an irrational number is the number of decimal places. All right, let's move on up to integers. So remember that integers are numbers that don't have fraction or decimal parts. And then up from integers are the whole numbers and the negative numbers. So whole numbers, though, is really kind of where we go from here. We are going to disregard negative, we're going to disregard fraction in this diagram. So integers don't have fraction or decimal parts. Whole numbers, though, can you show me a whole number of pizzas? So this I always think of number of pizzas. If you can represent a number of pizzas with this, then it's a whole number. So I mean, granted, I suppose you could show me 2.5 pizzas. So maybe I'll add the word, the number of whole pizzas. You can show me a whole 0 pizzas. There would be nothing on the counter. You can show me 75 pizzas, but you can't show me -5 pizzas. That's why a negative integer isn't a whole number. And then up from integer, or whole numbers, I mean, are the natural numbers. And our natural numbers I always like to think of as the kindergarten numbers. So kindergartners, they learn to count, 1, 2, 3, 4. And then first graders learn to count by 2s, 2, 4, 6, 8. Then maybe they also learn to count by 5, 5, 10, 15, 20, or by 10s, 10, 20, 30, 40, 50. So I like to think of the natural numbers as the kindergarten numbers. Sometimes the natural numbers are called the counting numbers as well. So counting and natural are words that can be used interchangeably. But notice that 0 is not in the group of natural numbers. There is no 0 in this group of natural numbers because you can't count by zeros. And 0 isn't really a number that shows up in nature. In nature, there's always going to be 1 blade of grass, or 1 tree, or 1 butterfly, or 1 person staring into the pond. But there's never going to be 0 blades of grass. I mean, there would be in the desert, of course, but you know what I mean. Okay, so natural numbers are my kindergarten numbers, or think, I'm going to put AKA, which stands for also known as counting numbers. Counting numbers. All right, so what are you going to have to answer if you are ever asked a question about the number system? So if I gave you number 3.25, 3.25 is going to be, of course, real. It's going to be rational because I could write it as a fraction. It's not an integer because it has a decimal part. It's not a whole number because I can't show you a whole 3.25 people. And of course, it's not a counting number because it's not a whole number. And it's really hard to count by 3.25. So that wouldn't be something a kindergartner could do. Okay, what about, how about the square root of 11? Well, the square root of 11 would be real. It's going to be irrational, though, because I could estimate what the square root of 11 is, but we don't have an actual number for the square root of 11. So the square root of 11 is going to be real, comma, irrational. It can't be written as a fraction, and it's going to have a decimal part, so it's not an integer or a whole number or a natural number. And then what if I gave you the number 5 plus 6i? Well, 5 plus 6i is going to be considered a complex number, and that is also non-real. So it doesn't even kind of belong on this chart because it's got that I. Just quick little thought bubble. You remember that I is equal to the square root of -1. All right, so if you haven't been writing down some of the notes that I've been writing down, I don't really need this check mark here, but if you haven't, I would like you to pause the video and go back and add all of this information to your notes. All right, so I'm hoping, and it is my intention, that you're going to follow along, you're going to write down what I'm writing down. And the first thing in class that I'm going to do tomorrow, or when I see you in Zoom, is I am going to be checking your notes to see that you've written in your own handwriting the notations that I've made on this page. All right, so let's talk real quick about a bounded interval. And with this problem, I'm going to give you a math problem, and then we'll talk about the different ways you can represent the answer in interval notation, as an inequality, and then using a graph, a number line graph, I mean. All right, so I'm just kind of shooting from the hip here. Here's example A. Let's solve 3x plus 4 is greater than 10. All right, so I need to isolate the variable, subtract 4 on both sides. 3x is greater than 6. I'm going to divide both sides by 3. I think by this point you can do that in your head, do that mentally. All right, so that's going to be my answer. Now I could show this on the number line. 2, 1 would be to its left, 3 would be to the right. Now my symbol is not underlined, so I'm going to use an open circle. This is red x is greater than 2, so I'm going to draw my arrow in the direction that is greater than 2. So there's my graphical representation that we've done in the past. Some textbooks make their number lines look a little bit different. So here I'm going to just put a parenthesis there and then draw my arrow like so. So a parenthesis is to an open circle, as a bracket is to a closed circle. And then in interval notation, so going back to this first column of representations, my interval is going to be from 2 to infinity. So where is this arrow headed? It's headed toward infinity. I'm going to use a wishy-washy parenthesis around 2 because 2 isn't a solution. 2 is not greater than 2. If this symbol right here were underlined, if it were underlined, then I could use a bracket, or I could say 2 can be equal to 2, or x can be equal to 2. But it's not. So I put a wishy-washy parenthesis around the 2. I always use a wishy-washy parenthesis around the infinity symbol because that's not a number. It's just kind of an idea. It's the direction we're headed on the number line, out toward infinity. All right, so those are our 3 representations for the answer to this problem. Now, we would say that this is an open interval. It's open because we've got these wishy-washy parentheses, we've got an open circle, and we've got an open-ended arrow headed toward the right. I'm going to stop there. If you're still a little not so sure on that, that's okay. We're going to work on that in class. We'll practice more of those later. All right, so turn your paper over and let's talk about the Cartesian coordinate system. So remember, the horizontal axis is x, the vertical axis is y. This is quadrant 1. Whoa, that was weird. My sleeve got in it. This is quadrant 2. This is quadrant 3. This is quadrant 4. That's all I need to say about that. Oh, you know what? I'm going to say one more thing, though. Everything in my first quadrant, everything is positive. My x values are positive, and my y values are positive. In the second quadrant, my x values will always be negative and my y values will always be positive. So in other words, to get to any point in that quadrant, I have to move to the left or negative, and I have to move to the right up. I have to move left and up. So left is negative, up is positive. All right, in the third quadrant, what's happening here? Well, my x's will be negative and my y's will all be negative as well. And then over here in the fourth quadrant, what's the only combination of positives and negatives that we haven't used? Well, x will always be positive and y will always be negative. Going from the origin to get to any point, like right here, to get to any point in the fourth quadrant, I have to go to the right, which is positive, and then down, which is negative. So that's how that works. That's supposed to be a plus. Does it not look like a plus to you? It doesn't look like a plus to me either. All right, so that's that. A couple formulas to throw at you here real quick. Distance formula. Distance is equal to big square root over the change in x's. Oh, my sleeve got added again. Quantity squared plus the change in y's, quantity squared. Add those squares together and take a square root. That'll give you the distance. The midpoint between 2 points. Our formula, the midpoint is an actual ordered pair. And to find the midpoint, you just average your x's, so add them together and divide by 2. And then you average your y's. Add them together and divide by 2. So the distance formula is going to give you a distance. Your label for a distance might be, I don't know, inches or units or meters. And then your midpoint isn't going to have a label. No label, because remember your midpoint is just, it's a point. It's a point. Okay, and then the last thing I want to go over, and then I'll sign off, is the standard form equation of a circle. This is something I think we're going to maybe need to work a little bit more on, because this is something we would have covered last spring, and well, I shall say no more about the craziness that was last spring. All right, so we're going to have to fit in 3 examples, so if you could please make that happen. Example 1, I'm going to give you the center of a circle. I'm going to tell you that the center is 5, -1, and I'm going to tell you that the length of the radius is 5. The radius is 5. All right, so what I can do then is I can write the equation of the circle. The equation of the circle will look like this. X something squared plus y something squared is equal to r squared. Okay, well, r is equal to 5, so I'm going to put a 25 there because r is 5 and 5 squared is 25. Now, my x-coordinate will be x minus 5 minus 5. And so that has to do with like the rational root theorem. So if x is equal to 5, then what was it as a root? Well, as a root, it would have been x minus 5. All right, then because my y-coordinate is -1, I'm thinking, well, y equals -1, and if y equals -1, then as a root or as a factor, that would have been y plus 1. So your x-coordinate and your y-coordinate are going to be the opposite of what you think. All right, let's do another example. So for number 2, this time I'm going to give you the equation and you're going to tell me the center and the radius. So if the equation is x minus 3 quantity squared plus y plus 1 quantity squared is equal to 81, then can you tell me the center and the radius? Well, my center is going to be, I'm going to do this kind of color coordinated with my problem from before. X equals 3. See what I'm doing there? I'm setting this equal to 0 and solving for x and solving for y. So my center is going to be 3, -1. And then my radius is going to be, remember that this, you're thinking, oh yeah, that's r squared. So what's the square root of 81? Well, the square root of 81 is 9. So my radius is 9. All right, I'm going to throw one more problem up here, and I'm going to kind of just let you think about this on your own. I need you to complete the square to find the, you're going to complete the square to find the center and the radius. So the equation is x squared plus y squared plus 4x minus 6y plus 12 is equal to 0. You are going to have to complete the square, blah, 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 and you're going to find me the center, and you're going to find me the radius. All right, so you can take 10 seconds or you can take 10 minutes on working on that right now, depending on how you're feeling today on our first night of homework. We're going to start with that though first thing tomorrow, and we'll work through it. All right, thanks everybody. See you tomorrow.